Okay, today's notes are going to be over the laws of exponents. So on the first one, we're going to talk about the multiplication property. So for our first example, I have 3 cubed times 3 to the 5th power. And the way we're going to handle this is if we're going to take that first 3 cubed and I'm going to expand it, the exponent tells me how many of the base I have. So the exponent 3 tells me I have 3 3s. So I have 3 times 3 times 3 times, then the second one, the exponent tells me I have 5 of the base 3. So I have 5 more 3s. 3 times 3 times 3 times 3 times 3. So then, to write my answer, I'm going to write the total. The exponent is going to be my total of number of 3s I have. So I keep the same base, which is 3. And I have 3 in black and 5 in red. So I have 8 3s total, so my exponent is 8. So the shortcut to doing this property would be just to add our exponents. So if I would have done 3 plus 5 in the beginning, I still would have gotten 3 to the 8th power without having to expand it. So our property is going to be, for multiplication, is to add the exponents. Okay? And it's important that they have the same base. So here's another example. With that same rule in mind, I have x squared times x to the 10th power. Instead of having to write 2 x's for this one and 10 for this one, I can add my 2 exponents since they both have a base of x. So I have a x to the 12th power. Okay, and then our last example for this property, I have 2 times x squared times y times 4 times x to the 3rd times y to the 5th. So we're going to take this one at a time. I'm going to do it my coefficients first. So I'm going to do those in orange. We are multiplying. So since we're multiplying, the coefficients don't get the same rule as exponents. So we still multiply the 2 and the 4. Okay, so 2 times 4 is 8. Okay, then I'm going to do my x's. And just like my rule, I'm going to add the 2 and the 3 to get x to the 5th. And then lastly, I'm going to do my y's. And it's important to note that if a variable or a number doesn't have an exponent, there's really a 1 right there. Okay, so I have 1y here and 5 here, so I have y to the 6th power. So that is my total answer. If you take each part at a time, we do our coefficients, then we do our x's and our y's. The problem isn't as scary as it looks. Okay, so that is our multiplication property for exponents only. Moving along, we have the power property. So a power means when I have an exponent inside the parentheses that has another exponent outside the parentheses, like our first example. Okay, so we're going to start with the outside parentheses, which on this example is the 4. The outside parenthesis tells me how many I have whatever's inside. So this 4 tells me I have 5 cubed 4 times. So I have 5 cubed times 5 cubed times 5 cubed times 5 cubed. Okay? And I meant to do those in orange, but so the 4 told me I had 5 cubes. Now the 3 on the inside, as now there's 4 of them. 1, 2, 3, 4 of them. And I'm going to do the cubes like I did the multiplication property above. Okay, so on this first 5 cubed, I have 3 5s. 1, 2, 3. Then I have 3 more. 1, 2, 3. And 3 more. 1, 2, 3. And 3 more. 1, 2, 3. Whoops. My bad. I meant to put a 5. Okay, so now just like our multiplication property, my base stays the same. And now I count the number of 5s I have, and that's going to be my exponent, which is 12 of them. Okay, so now I look at my final answer, and I look at the original problem. I had a 3 and a 4. The shortcut, instead of having to expand all these 5s, would be to multiply the 3 times the 4, which is 12. So my exponent would be 12. So our power property means that we multiply the exponents. And then I'll put on here note to every thing inside the parentheses. Oops, can't spell. Okay, so moving along. My next example with the rule that I just showed you why we do it, I have y cubed to the 11th power. Instead of having to do 11 y cubes and then expanding all the 3's, I could just multiply the 3 and the 11, so I get y to the 33rd power. And that is way easier than having to write out 33 y's. Okay, and then the last one, just like the previous one, it looks scary because there's a lot of parts to it, but we're going to take each part at a time. What we're going to do first is make sure that every part of the parentheses has an exponent, including the coefficients. So for example, my 6 is my coefficient. It doesn't have an exponent written out, but it has a 1 that's there that's not really written out. The x has a 4, the y has an 8, and the z doesn't, but anytime there's no exponent, I need to know that there's a 1 as an exponent right there. Okay, so we're going to, just like the previous one, we're going to take each part at a time. I'm going to start with the coefficient 6, and I'm going to multiply the exponent of the 6 to the exponent that's on the outside. So I do 1 times 4, which is 4. So 6 to the 4th. Then I do my x's. Let me write it this way, sorry. So I did 6 to the 1st times 4, which is 6 to the 4th. There you go, so you guys don't get lost. Then I'm going to do my x's, which is x to the 4th times 4. That gives me x to the 16th. Then I'll do my y's, and I'll do y to the 8th times 4, which is y to the 32. And then the last one is the z to the 1st times 4. So I get z to the 4th. Okay, and my final answer is this one right here in blue bubble. Okay, so all 4 parts of the inside of the parentheses got multiplied by 4. And that's what I showed you on this part right here. I got my final answer by multiplying all of them by 4. Okay, next property is called the division property. Okay, so our first example, we're going to start off by expanding. And we're going to take the numerator and the denominator one at a time. Okay, so on the top of my fraction, I have 12 3's. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and on the bottom I have 5. 1, 2, 3, 4, 5. All right, so now, as you should know by now, anytime we divide something by itself, we call it canceling out, but it really goes away and it becomes a 1. Okay, but we're going to cancel out, but we need to know that it's a 1 that's canceling out 2. So every pair of 3's, one on top, one on bottom, cancels out, like so. So this 3 will cross out with that 3, this 3 with this 3, and we keep going until we can't cross out anymore. And that was my last 3 on the bottom. So now I'm going to count how many 3's I have. I have 1, 2, 3, 4, 5, 6, 7 3's. And since those 3's were on the top, I can just write 3 to the 7th power as my answer. And since there's no 3's on the bottom, it technically has a 1 on the denominator. So really it's just 3 to the 7th, like this. Okay, so my shortcut by looking at my original exponents, the 12 and the 5, would be to subtract my top exponent from my bottom exponent. So 12 minus 5 is 7. So that would be the shortcut instead of having to write out all the 3's like we did in this example. So my rule is subtract the top exponent from the bottom. Okay, so same thing. Now I know my rule, so instead of having to write 17 y's, I do 17 minus 6, which is 11. Y to the 11th power. All right, now this one, as you may notice, there's a pattern. We're just going to take each part at a time. So I'm going to start with my coefficients, which are the 3 and the 9. Okay, these rules that we're talking about are for exponents, and 3 and 9 are not exponents, they're coefficients. So we treat them like regular numbers, and we're just dividing. 3 divided by 9 is equal to 1 over 3. Then I do my x's with my rule. So I have x to the 10 minus 4, that gives me x to the 6. Okay, now I'm going to write this nicer, which is the same thing as x to the 6 over 3. Okay, and it's important that the 3 stays on the bottom. It can't be brought up to the top, okay? And that 1 is really still there, but we don't have to write it. This 1 right here, what just happened? Sorry. This 1 right here is still up here with the x, but we don't normally write the 1. Okay? All right. We have 2 more properties. All right, the next one's called the 0 property. So I have 100 to the 0 power. Now, what this means is if I have anything to the 0 power, my answer is always a 1. And here is why. If I said I had this fraction right here, 100 to the 0 can be written as 100 squared over 100 squared. Okay? From our previous division property, we found out that we can expand that to have 100 times 100 over 100 times 100. Okay? And we cancel out. This cancels out with this, and this cancels out with this. And you might be tempted to say 0, but like I mentioned above, when we're canceling with fractions, it's not going to 0, it's going to 1. So when I cross out this 100 with this 100, that equals 1, because 100 divided by 100 is 1. Same thing here, 100 divided by 100 is 1, so I have another 1. 1 times 1 equals 1. Okay? And it doesn't matter which exponents I picked for the squared, as long as there's the same on the top and the bottom. Like we said, on division, I can rewrite this by subtracting my exponents. 2 minus 2 is 100 to the 0 power, which is the same thing I just got here, which is 1. So what you just need to know, that was a long story short, kind of. If you have anything to that 0 power, it equals 1. So anything to the 0 power equals 1. Okay, so we don't have to do any type of fraction stuff here. I have 0 on the outside, so the 0 goes to the x and the y. So my answer is 1. And then for the next one, since the 0 is on the outside, the 0 goes to the 3. And here. So the 0 goes to the 3. Because remember, 1 times 0 is 0. Then A, 2 times 0 is 0. And B, 4 times 0 is 0. Since they all have a 0, my answer is 1. Because like we said, anything to the 0 power is 1. And this property, the multiplying I just did, is the power property that we just talked about before up here on our power property. Okay, but now this one's a little tricky. Notice that not everything is inside of my parentheses. Okay, the 3 is on the outside. Okay, it's by itself, it's not inside. So the 0 only goes inside to the 2, the A and the B that are inside. So I'm going to do the A first. So I get A squared times 0, which is A to the 0. Then I do B to the 4th times 0, which is B0, but I still have that 3, okay, that doesn't have a 0 exponent, okay? So now the A to the 0 is just 1, and the B to the 0 is 1, and the 3 is still in the front. It didn't get affected by the 0. So I multiply the 3 times the 1 times the 1, which equals just 3. Okay, so this one was a little different from this one because on this one above, all 3 terms were inside of the parentheses. So just be careful on the 0 property. Okay, last one is called the negative exponent rule. So negative exponent rule is pretty much in math, it's improper to write an exponent as a negative as in your final answer. So to make an exponent not become negative, we move where it's located. Okay, so let me just pick 2 numbers that when I subtract them, it gives me a negative 4. So for example, 3 to the 6 and 3 to the 10. 6 minus 10 is negative 4. Okay? So notice that this looks like our division rule that we did above. Okay? Our rule said subtract the top from the bottom. So if I subtract 6 minus 10, I get 3 to the negative 4. Okay, so I'm just showing you this to show you that these two are the same. I just wrote them differently. Okay, so now look here. I'm going to expand this guy right here. I have 3 6s on the top. 4, 5, 6. And 10 on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just like the division rule, I'm going to cross out pairs that are on top and bottom. So this 3 goes away with that. These 2, these 2, these 2, these 2, these 2. And now I have no more 3's to cancel out, but notice where my 3's are located. They're all under my fraction. And if we go back and look at this example, all my 3's were on top. Okay? So, because my 3's are on the bottom, I have a 1 on top, because remember when we cancel, it goes to 1, not 0. I have 1 on top and 3 to the 4th power. Okay, so if I ever want to make my exponent not negative, I move it in the opposite direction that it's at. So if it's on top of the fraction, it goes on the bottom. If it's on the bottom, it goes to the top. Okay, so this is the answer to this one. Okay, so our negative property is move the negative exponent to the opposite side it's on. Okay. So this next one is similar to the one I just did. I don't have to show all this fraction and the crossing out. I need to make it not negative. So since this is not a fraction, I can make this a fraction by putting a 1 underneath. So now to make it positive 6, I just move the x to the 6 underneath and the 1 goes on top. So they pretty much flip. So now my 1's on top and my 6 is now positive. Okay, and I didn't really show that on this one. I can rewrite this 3 to the negative 4 with the 1 on the bottom, and then it moves down to become positive. So I still get the same thing that I showed you in the green. All right, last one. So just as all the other ones, we're going to take it part by part. I'm going to do the coefficients first, which is the 16 and the 2. The 16 and 2 are not fractions, so I divide them like normal numbers. 16 divided by 2 is 8. I don't like that there. It's 8. And now I do my exponents. Okay, the ones in the x's in orange. Okay, I want to make this 10. Let me pick 2 different colors. Let me do orange on the top. I want the x and the negative 10 to become positive, so I move, what is happening? I move this one down. Okay, so now my 10 is on the bottom. Oops, what am I doing? Sorry, guys. Okay. And now the x squared, I don't want it negative, so I move it to the top. So now it's on top. And now my final answer, we can't forget about the 8. Since 8 is not a fraction, I can write it on top with the x squared. So my final answer would be 8x squared over x to the 10th. Once all my answers are positive exponents, I can, I'd be done. But real quick, I'm sorry, I forgot. My x's, they have the same base, so I still have to get rid of them. Remember, we do top minus bottom, so 2 minus 10 is negative 8. So this is 8x to the negative 8, but I don't want that negative 8, so I put it on the bottom so that it's not negative. So I have 8 over x to the 8th is my official final answer. Okay? All right, so this is going to be your cheat sheet for all the rules and some examples for you to follow. So now here's the rest of our notes. We're going to do a couple examples together, and we made this table so that you can, with steps that you should take to get towards your final answer. Okay, so we'll start by first on step 1 to get rid of the parentheses by multiplying the exponents. Okay, just like before we multiply, make sure each part of the term has an exponent. So the 12 has an exponent of 1. X is good, Y is good, Z is good. Okay, so now I multiply this 2 to every exponent in my problem, in the top. Okay, so 12, 1 times 2 is 2. Then I do X, 2 times -4 is -8. And then my Y, 3 times 2 is 6. And then my Z is -6. Okay, now I do the bottom. Make sure everything has an exponent. This -3 has an exponent of 1. And the rest of them are good. So -3 to the 3rd power. X to the -6. 0 times 3 is 0, and then Z, 4 times 3 is 12. Okay, so we first start by getting rid of our exponents on the outside. Okay, so then step 2 is make sure that all our exponents are positive. Okay, the coefficients, like -3, can be negative, but my exponents have to be positive. So I'm going to start with the top. This X is going to move down to make it positive. Okay? Then my Z also has to move down to become positive. So my top's now good. And then check the bottom. Remember, the coefficient can be negative, but the exponents can't. So this -6 can't be down there, so I'm going to move it up so it's positive. All right, so now I write my final answer with all the movement. So the 12's good to stay. That 8 moved down, but the 6 moved up, the X to the 6th. The Y was good, and the Z's went down. So there's no Z's on top now. The -3 is good. I already moved that 6 up. It's right here. The Y to the 0 is good. And I forgot to write the X, sorry. The X to the 8th moved down. Y to the 0. Z to the 12. And I brought down the 6 Z's. Okay, so let me show you with color. This was the 8 that moved in green down. This is the 6 I moved up. And this is the Z to the 6 I moved down. So those are the ones that moved to help you see it better. Okay, so now once all our exponents are positive, now we're going to combine if they're on the same level. So for example, on the top, there's not another X with a different exponent or another Y. Okay, so I just leave it like that. But I can also simplify 12 squared. I know 12 squared is 144. Okay, there's no other X's to add on the top, so those are good, and the Y's are good also. Okay, then I do -3 cubed is -27. And then there's no other X's on the bottom to combine, so those are good. There's no other Y's. And the Z's, so here I can combine these two Z's. And remember, we're multiplying on the bottom. So I do 12 plus 6 is 18. So there's 18 Z's on the bottom. Okay, and then close to being done. Now we're going to subtract. The exponents are on opposite but the same base. So for example, we're going to do our X's. Okay, so I have 144 staying and -27 staying. So I have 6 on top, 8 on the bottom. So I do 6 minus 2 is negative 2. But it's going to stay on the bottom, the 2 x's. Okay? Now, the 6 minus 0 is just 6, so there's 6 y's. And there's no z's to subtract, so all the z's stay on the bottom. And so now our simplify step would be, does 144 and negative 27 reduce? And so it reduces to 16 over 3. And then my y's would stay on the top, my x is on the bottom, and my z's on the bottom. Okay? And then sorry I didn't do this good. Those two. And that's my x. And then my z's didn't have any 1, so they stayed on the bottom. Okay? All right, so let's try another one. All right, I'm going to go a little faster on these since I took the first one slow. So to start off, we're going to make sure everything has an exponent and we multiply by the outside. So 8 has a 1 exponent, c has an exponent of 1, and the rest are good. Okay, so I'm going to do 8 times negative 1 is negative 1. C times negative 1 is negative 1. D times negative 1 is negative 9. And 0 times negative 1 is 0. On the bottom, there's no parentheses to multiply by, so everything stays the same on the bottom. Okay, next step, we're going to make sure all of our exponents are positive. Okay, so 8 has a negative 1, so it's moving down. My C has a negative 1, so it's also moving down. My D has a negative 9, so it's also moving down. And the F's the only one that's not negative, so it stays up. Okay, then on the bottom, the C is negative, so it's going to move up. The D is good, and my F is negative, so it's going to move up. Okay, now to show the answer once everything's moved. Okay, here's my fraction. The 8 moved down with the 2. The C moved down. And the D also moved down. The F stayed up. Okay, the C moved up. The C to the negative 8, which is now positive. The D to the F, or D to the 4 stayed down. And then the last one is the F to the negative 3 moved up. Okay. All right, so that's all of our movements. All right. So now, this 2 should have been this color. All right, so now we're going to add and combine all of our exponents to have the same base. So on the top, these 2, we're going to add them. So we're going to add these. 0 plus 3 is just 3. So I have C to the 8th, and I add those F's, and it's still 3. Then on the bottom, I have 8 to the first power, which is 8. Then I have 2 to the first power. Then there's nothing on the bottom that will combine. So those, oh, I lied. Sorry. So then my D's also add on the bottom. So I get 9 plus 4 is 13. Okay. So the D's are right there and the F's are right here. Okay. All right. So the next step is we're going to subtract the exponents with the same base that are on top and on the bottom. So starting with my C's. C is the only letter that has 1 on top and 1 on bottom, so I subtract top from bottom. So I have 8 on top minus 1 on the bottom, I have 7. So C to the 7. There's no f's on the bottom to subtract, so they stay on top. I have an 8 times 2 on the bottom, and there's no d's on the top to subtract, so I have d to the 13th. Then my last step will be to simplify, which the only thing left to simplify is going to be this 8 times 2 right here. So my final answer is c to the 7, f to the 3rd. 8 times 2 is 16, d to the 13th. Okay, next one. Notice this 2 exponent's a little different from the one up top or the one that we just did. And that's because this 2 is going to the top and the bottom. Okay, so the 7 has a 1 exponent, the a has a 2, the b has a 5, the 9 has a 1, the a has a 3, and the b has a 6. Okay, so now we're going to multiply 2 to every exponent on the top and the bottom. So 7, 1 times 2 is 2, a, 2 times 2 is 4, b, 5 times 2 is 10, then 9, 1 times 2 is 2, a, 3 times 2 is 6, and then b, 6 times 2 is 12. Okay, then we're going to make sure all of our exponents are positive, and they're all positive, so on this one, it's not applicable, so we skip this one. Then we go to the next one. We're going to combine exponents that are on the same level of bases. Okay, so I go back to my first box. There is no other a's on top to combine, or b's, and same thing for the bottom. So the third step is not applicable either. All right, so then the fourth step, we're going to subtract our exponents that have the same base but are on different levels. So one on top, one on bottom. So for example, my a's. So I have 7 squared and 9 squared that are going to stay there for now. I have 4 a's on top and 6 on the bottom, so I do 4 minus 6 is negative 2. So that means that the a squared goes on the bottom. And then I have 10 on top, 12 on the bottom. That's 10 minus 12 is negative 2. So the b squares stay on the bottom. Okay, my last step is to simplify. So 7 squared is 49. 9 squared is 81. And my a stay and my b stay. And that's my final answer. Okay, next one. The top doesn't have anything to multiply in, but the bottom, we're going to multiply the 4 to everything on the bottom. Okay, so let me just write the top real quick. 9, q to the negative 7, r to the negative 1, s to the 3rd. The 3 has an exponent of 1, and the rest are fine. So 3, 1 times 4 is 4, q, 4 times 4 is 16, r, 0 times 4 is 0, s, negative 3 times 4 is 12. Next, we're going to make sure that all of our exponents are positive, so we're going to move them around if they're not. This q to the negative 7 is going to go down to be positive. This r to the negative 1 is going to move down to become positive, and the rest on top is okay. On the bottom, only the s to the negative 12 is going to come up to become positive. So now I'm going to write that down. 9 s cubed, and then the s to the 12th is coming up. Okay, then on the bottom, 3 to the 4th, q to the 16th, and then the q to the negative 7 came down to become positive. The r to the 0 stayed, and the r to the negative 1 came down to become a positive 1. And that's everything. Okay, so now we're going to combine terms that have the same base, that are on the same level. So I'm going to do these two s's because they're both on top, and I'm going to add them since we're multiplying. So I have 9s, 3 plus 12 is 15 s's on the top. Then I have 3 to the 4th. And on the bottom over here, I have these q's to add and these r's. So the q's give me 16 plus 7 is 23. And then 0 plus 1 is 1r. All right, then we're going to subtract the exponents that are on different levels. So there's no s's on the bottom, no q's on the top, no r's on top. So there's nothing to subtract. So this step is not applicable. Okay, and then our last step is to simplify. So the only thing to simplify would be 3 to the 4th power, which is 81. And let me write this smaller. Okay, so I have 9s to the 15th. What is happening? 9s to the 15th. 3 to the 4th power is 81. Q to the 23 and r to the 1st power. Okay, and now I just have to reduce. 9 divided by 81 is going to be 1 over 9, which is just going to be s to the 15th over 9, q to the 23rd, and then r. And you don't have to write the 1 for the 1st power, but you can if you'd like to. And that's our answer. Okay, last one. Bear with me. Okay, this last one is similar to the one I did right here. Okay, so the -3 is going to multiply to everything on the top and everything on the bottom. Okay, so we need to make sure everything has an exponent. The 4 has an exponent of 1. This 4 on the bottom has an exponent of 1. And so do the x and the y. So now I just multiply everything by -3. So for the 4, 1 times -3 is -3. For the x on top, 0 times -3 is 0. For the y on the top, -2 times -3 is a positive 6. And for the z, 3 times -3 is -9. On the bottom, 4 times -1 is -3. X is -3. And y is also -3. Okay, now we're going to make all our exponents positive by moving them around. This 4 on the top has to move down. And the x is good, the y is good, and this z on top has to move down. Now on the bottom, the 4 has to move up. The x to the -3rd moves up. And the y to the -3rd also moves up. Okay, so now I write my final answer. Or not my final, sorry. Okay, so then this 4 in orange to the -3rd moved down. X to the 0 stayed. Y to the 6 stayed. And the z to the -9 moved down to become z to the +9. Then the 4 to the -3 moved up. Then the x to the -3 also moved up to become a +3. And lastly, the y to the -3 also moved up. Okay, so now we're going to combine the exponents that have the same base, they're on the same level. Okay, so what that means is all my x's, so I'm going to circle them in red, we're going to add together. So 0 plus 3 plus 3. Okay, so I get 4 to the 3rd. 0 plus 3 is 3, plus 3 is 6. So I have 6 x's on the top. And there's no y's to add on the top, so that stays the same. On the bottom, there's no numbers or variables to add, so it stays the same. Okay, so the only thing that changed was those x's. I added all of them. Okay, next step, we're going to subtract our exponents that are on the top and also on the bottom. So there's no x's on the top to subtract. There's no, sorry, on the bottom. Same thing for the y's. And for the z's, there's none on the top to subtract. But I do have my 4's. Okay, so I have 3 minus 3 is 0. So those cross out to 1. Okay, so I get x to the 6th, y to the 6th, over z to the 9th. And there's no more need to simplify. So this is my answer on this problem. Okay, and that is it. I know it seems like a lot, but once you get the hang of it, they go a little faster.